Okay, so we're going to prove the alternate interior angle theorem. And this is one of the first types of proofs that we did in class. So let's look at the aspects of proving this theorem. So the first thing I'm going to do, as we do with all proofs, the alternate interior angle theorem, remember, states, okay, the alternate interior angle theorem, that theorem states that if the lines are parallel, then the alternate interior angles are congruent. Well, we want to prove that this is true. We want to prove that indeed, if the lines are parallel, that the alternate interior angles are congruent. So we're going to do a two-column proof here, and we're going to have our statements, and we're going to have our reasons. You always have a two-column proof. You have your statements and you have your reasons. Okay. What do you always start the proof off with? You always start the proof with what you're given. So I'm given that line H is parallel to line K. So I'm going to put H is parallel to K. And the reason I know this is because it's given. They tell me up here, plain as day, H is parallel to K. So I know that it's given. If you want to, you can actually come over to your line and mark it so you remember they're parallel since that's been established, but you don't have to. Okay, so let's look for our next step. All right, when we prove this 2 and 3, we're assuming we don't know anything about alternate interior angles. We're just proving this. So what else do you see that we can use? Remember, theorems can be proven. Postulates we don't prove. It's just something that's assumed to be true. So I see a pair of corresponding angles. And there is a postulate for corresponding angles. So I'm actually able to say that angle 1 is congruent to angle 3 because of the corresponding angle postulate. And if you remember what the corresponding angle postulate is, that says that if the lines are parallel, then the corresponding angles are congruent. So since the lines are parallel, I established that here, I can now say, because of the corresponding angle postulate, that 1 and 3 are congruent. Okay? And it depends on who you have doing the proofs, how many steps you do. Some people will want you to say 1 and 3 are corresponding angles by the definition of corresponding. And then they'll want you to go ahead and add that extra step in there. So instead of this being step 2 would be 1 and 3 are corresponding angles by the definition of corresponding. Again, it's all dependent on whose proof you're doing and who wants you doing the proofs. So let's look at the next step. 1 and 2 are also a special kind of angle. I'm trying to tie 2 and 3 together. I've tied 1 and 3 together, so I want to get 2 in there somehow. Well, I know that 1 and 2 are vertical angles. So I can say angle 1 is congruent to angle 2 by the vertical angle postulate. The vertical angle postulate is what says if they're vertical angles, they're congruent. So that enables me to say that 1 is congruent to 2. So now I'm at a spot where I can actually finish this off. So for step number 4, let's use a different color so y'all can see that a little bit better. For step number 4, I can now say by the transitive property, if 1 is congruent to 3 and 1 is congruent to 2, then 2 must be congruent to 3. And the reason I know that is the transitive property. The transitive property tells me 2 is congruent to 3 because 2 and 3 are both congruent to the same thing. So there's your proof of the alternate interior angle theorem. Like I said, some people will make you actually state 1 and 3 are corresponding and make that an extra step, then state that 1 and 2 are vertical, but we're not going to require that. So as long as you can follow that logic, then you've completed the proof.